Hey guys, welcome to lesson 714, day 2. We are going to now start looking further into the unit circle and start looking at coordinates, as well as using the Pythagorean theorem to find coordinates. And that will make a lot more sense as we get into this a little more. For the cosine graph, I already talked about that a little bit in class, so I won't do that right now. We're just going to go ahead and go straight to the coordinates. So something that's really important to understand is that when we were talking about sine and cosine as vertical and horizontal distances, there is a specific reason for that, right? You have hopefully noticed that there's been like this graph axis on every single unit circle that we've looked at, and the reason for that is because we are operating on a coordinate system. So if I were to take a look at any point on the unit circle, let's say we want to consider this point. So because we're operating on a graph, naturally we would have x and y coordinates. But because we've been talking a lot about sine and cosine, what's important to realize is that since x typically represents the left and right movement on a graph and y represents the vertical movement on a graph, that's what we're replacing with cosine and sine. So now cosine will represent the left and right movement on our graph versus sine representing the vertical movement. Okay, so they are pretty directly replacing x and y, and it makes sense because we've used them so far as vertical and horizontal distances. So instead of x and y, any point on the unit circle will now have coordinates of cosine of the angle, comma, sine of the angle. So let's go ahead and see what that's going to look like in a couple different kinds of problems. So for this one, this is just your basic problem regarding the coordinates. So if I give you an angle of rotation, I have given you 135 degrees here, and I said to find the coordinates. That means we need to find the cosine and the sine. So this is just a calculator problem. In fact, let me write out this whole thing. Cosine of 135, comma, sine of 135. All right, so in our calculator, we're just gonna turn it on. And we'll say, all right, cosine of 135 and sine of 135. So cosine is negative 0.707 and sine is 0.707. So for my coordinates, it will be just that, negative 0.707, comma, 0.707. And that is my answer. All right, the reference angle is the angle that is inside of the triangle. Hopefully by now we understand that this angle of rotation isn't going to be the reference angle, unless if we're in the first quadrant, then it's small enough. But when we venture past there, we have to do a little bit of work to figure it out. So if this is at 135, and we remember that the entire rest of my unit circle has some particular labels too. So now my angle, or my triangle, is between 135 and 180. So in order to calculate that angle, all I have to do is a little bit of subtraction. 180 minus 135. 180 minus 135 will get us there. So that gives us a 45-degree reference angle. This tells us that this angle inside of the triangle is 45 degrees. All right, this is just like the second problem on your My Open Math practice for today. All right, so on this page we have a different kind of situation. Now I'm giving you the sine, or it could also be cosine, it's just these examples are sine, and you have to find the coordinates. So really I've given you half of the answer, and you have to find the other half. So what's important here is to recognize that because I gave you sine, you need to label your triangle accurately. Sine represents the vertical distance, so that negative root 3 over 2 is going to go on this red side, because that's the height. We don't know what the blue side is, which represents the horizontal distance, which also represents the cosine. We know that that black line is length of 1 because that's our radius of our unit circle always. So now that we've labeled our triangle, we know 2 of the sides, we don't know the third, we can use our good friend Pythagorean theorem. So a squared plus b squared equals c squared. When we label our triangle, just remember that the hypotenuse always has to be the side c. And then after you label your c, I don't care which one you label as a and b. I typically like to make the smaller one a, but it doesn't matter. So now we plug in all of our values where they belong in the formula. So instead of a squared, I will write x squared because my a is x. Instead of b squared, I'll plug in negative root 3 over 2 squared because my b is negative root 3 over 2. And then instead of c squared, I will put 1 squared because my c is 1. So from here, it's just a game of simplifying and then solving for x. So let's calculate whatever we can. To square this, I do want you guys to keep things as fractions. So if you need your calculator to square this, that's okay. But just watch how I do it so that you are able to keep things as a fraction. Anytime you're trying to square a fraction, that's the same as squaring the top on its own and squaring the bottom on its own. So if I want to square negative square root of 3, this is how I would do it. It's very important to remember that if you're ever squaring something that's negative, you need to give it its own set of parentheses or it will not be, oops, correct. So, okay, and I get an answer of 3. So I know that the top, when squared, is 3. And the bottom, 2 squared, that's just 4. 1 squared is 1. And then now we want to get the x term by itself. So in order to do that, we need to move 3/4 to the other side. Because it's being added, I'm going to subtract it from both sides. I want to do the opposite. And again, if you want to use your calculator for parts like this, it's totally fine. Just make sure you know how to keep things as a fraction. So if you have 1 minus 3/4, you could just imagine like if you have a whole, like a whole pizza, and you take away 3/4 of it, you're still going to have a quarter, right? If you had like cut your pizza into 4 giant slices and ate 3 of them, you'll have 1 left. So you'll have 1/4. Okay, at this point, we're really close to having x alone, but we need to take the square root of both sides because we don't want that square there. So that tells me that my answer for that is the square root of 1/4. Just like squaring fractions, if you want to square root fractions, you can do it to the top, do it to the bottom. So it's kind of like this. Square root of 1 is just 1, square root of 4 is 2. So this is my answer for x. So now that I've found my x value, which is my cosine, I can write my answer as full coordinates. So it's cosine comma sine, right? Cosine comma sine. So for me, my cosine was 1/2. My sine, they had already given me, it was negative root 3 over 2. Okay, and remember, the cosine represents that blue line. That sine represents the red one. All right, and that is the answer to that question. All right, let's do one more example. Okay, this time I gave you a new sine value. It's negative root 2 over 2. So just like we started before, you want to label your triangle accurately. Because it's a sine value, we got to put it on the vertical distance, so that's going to be the red one. All right, so negative root 2 over 2. We're looking for the blue. We'll call that x. And as usual, the hypotenuse is 1. So label your triangle with A, B, and C just like before. The 2 legs are A and B, and then the 1 is always going to be your C. So we plug into our formula. Instead of a squared, we will write x squared. B squared becomes negative root 2 over 2 squared. Then c squared becomes 1 squared. So again, this is the calculating stage. So when we square this term right here, the top negative root 2 squared becomes 2, and 2 squared on the bottom becomes 4. 1 squared is 1. And just like before when we subtracted the 3/4, this time we have to subtract the 2/4 because we want to move it away from that x term. So 1 minus 2/4 ends up being 2/4. Again, you can imagine this as your giant pizza. If you have 4 big slices and you take away 2 of them, you still have 2 out of the 4 left. Some of you might be tempted to change this to 1/2. I would say don't do it, and I know usually I like simplified fractions, but for this particular purpose, leave it as 2/4. So now, our last step in Pythagorean theorem is to take the square root of both sides so that x can be completely alone. We don't want it to be squared. So our final answer then, once we square root the top and the bottom, is the square root of 2 over 2. So we have found our cosine. So we can write our final answer as cosine comma sine. There is one thing, though, that we have to watch out for. Even though we do all this work, and we got all these answers, there is something that is incorrect about this, and that's where you have to be very careful and double check your own self. So you look at the location of this triangle, and you realize that, first of all, it's underground. They told us that the sign was negative because it's underground. We didn't have to worry about it because it was part of the problem. However, it's really important that you notice that we're also on the left side of the circle. And because we're on the left side of the circle, we should have a negative cosine because, on a graph, left side of the x-axis is where the negative x values are. So we have to add a negative sign there ourselves simply because we know that the cosine should be negative at that spot. I'm going to make a note of that here. So we had to add the negative sign because we're on the left side of the circle. The left half of the circle, I should say. Okay, this is super important. So if you're trying to do this problem in open math and you're like, man, I did all the work, what's wrong? Just check to see if you need to convert anything to being negative, because this work is never going to give you a negative answer, but sometimes your answer does need to be negative. So that is the final answer. Give the open math problems a try and let me know if you need any help.